And finally, we see here that x to the third times x to the fourth, really, the exponents are being added. So it's much better to remember what the definition of a raise to the third power or raise to the fourth power concept means, and then to be able to rebuild it than to just memorize a rule. Because memorizing rules gets us in trouble. Sometimes we forget how to use them, and only logic can allow us to remember how they actually work. Okay, so why is this important? Well, sometimes we want to multiply functions together. So let's just say f of x is equal to x squared, and g of x is equal to 3x plus 3. Okay, in certain contexts, and I'm gonna omit the of f of x thing, f of x and g of x, and I'll just say, suppose we want to multiply f times g. Well, that means f is given by x squared, and g is given by 3x plus 3. So we'll see an example of this next week where we will have to actually do something like this. Okay, well, we're using kind of multiple concepts here. We have the distributive property, which says distribute this guy in to both terms. So we'll have x squared times 3x plus x squared times 3. Okay, well, oh my gosh, how do we multiply this stuff together? Now, first of all, I like to think of this as three pieces. I have x squared times 3 times x, plus I have x squared times 3. Okay, well, because order of multiplication doesn't matter, 2 times 3 is the same thing as 3 times 2, I can actually write it this way: 3 times x squared times x. Plus, well, here I have x squared multiplied by 3. That means I'm going to have 3 copies of x squared. That's the same thing as that right there. Again, order multiplication doesn't matter, so 3 times x squared is the same thing as x squared times 3. And, okay, well, now I can use my property of exponents. So this means 3 times x, and then the last x, plus 3x squared. So I have 3 copies of x here, meaning I will have 3x to the third power, plus this guy, which is 3x squared. Now I am done. That has taken things farther than we needed. And in fact, we get a function that we don't quite recognize. This is not a quadratic. It doesn't have just an x squared power. It has an x to the third power. That's something you might experience more in a different class. But this is sort of the application of it. Now, for the people, when you get quick at this, you'll end up being able to see. Well, first of all, this is x to the first power. X squared times x to the first will be x to the 2 plus 1. I'll have 3 copies of that, giving me 3x to the third, plus 3 copies of x squared will give me plus 3x squared. So you can take as many steps or as few steps as you need to take, but this is sort of rebuilding the logic. If we ever forget something, we should be able to reconstruct it. We'll stop with the final thing, which is this idea of what people refer to as FOIL. Okay, now I won't refer to it as FOIL. Let's say we want to multiply two expressions together like this. So what does this mean? Well, first of all, let's start off with a simpler example. Suppose I have a square plot that's 3 by 3. Its area is 9 square units. So if this is 3 feet by 3 feet, I have 9 square feet. And we'll say it's in feet. Okay, well, if I extend my garden plot, let's say that's what this is, by 2 feet this way, and I extend it by 1 foot this way, what's the new area of my plot? Well, in this context, 3 plus 2 is 5, 3 plus 1 is 4, so really my plot is 5 by 4, which is 20 feet squared. However, I can actually think about this as being parsed up. I can think about this as 4 separate pieces. Well, this piece will be 3 wide, 2 long, so that'll make it 6 feet squared. This one will be 3 feet by 1 feet, which is 3 square feet. And this one will be 1 foot by 2 feet, which is 2 square feet. Now I add up all these areas together to represent the whole. 9 plus 3 is 12, 18, and I get 20 square feet. I get the exact same thing. That's exactly this concept of foiling. I don't want to record another video, so I'll stop here, but I'll let you think about how this works, and we'll address this on Monday.